When you look at Jupiter through a telescope, it's easy to miss that orbiting this gas giant is a hidden world, Ganymede, the largest moon in the entire solar system. This icy giant is bigger than Mercury, holds more water than all of Earth's oceans combined, and beneath its frozen crust may hide answers to some of humanity's biggest questions. Where do we come from? Are we alone? And where might we go next? Let's dive into 10 mind-blowing facts that prove Ganymede is so much more than just a moon. Ganymede, bigger than a planet. Ganymede's diameter is about 5,268 kilometers, 3,273 miles, making it not just the largest moon in the solar system, but bigger than the planet Mercury. If Ganymede orbited the Sun directly, we would likely classify it as a planet. Its mass is about 2.02 × 10^3 ke, more than two-thirds the combined mass of all Jupiter's other moons. Surface gravity on Ganymede is about 1.43 mems2. You'd weigh 7x less than on Earth, but about twice as much as on our moon. A colossal reservoir of water, oceans, hundreds of kilometers deep. Under Ganymede's thick icy crust lies a global subsurface ocean estimated to be as much as 100 kilometers, over 60 miles, deep. Scientists believe Ganymede's ocean contains several times more water than all of Earth's oceans combined. The ocean is likely layered, with multiple levels between the icy shell and the rocky core, potentially creating a dynamic environment. The presence of so much water is a key reason Ganymede is considered a top candidate for hosting extraterrestrial life. Unique magnetic field. A miniature Earth in the moon family, Ganymede is the only moon in the solar system with its own intrinsic magnetic field. This suggests it has a liquid iron or iron sulfide core just like Earth. Its magnetic field creates a mini magnetosphere inside Jupiter's gigantic magnetosphere. This interaction produces unique phenomena, including auroras on Ganymede's surface, much like Earth's northern lights. A surface mosaic of ancient and young terrains. Ganymede's surface is a stunning patchwork of light and dark regions. Light areas are younger, icy flows, while dark regions are old, cratered landscapes. The moon is covered in grooves, ridges, canyons, and impact craters, some billions of years old, others surprisingly young. Many of these features are evidence of tectonic activity and possible cryovolcanism, ice volcanoes. The average surface temperature is about 160 degrees, 256 degrees, making it one of the coldest places in the solar system. Atmosphere? Barely there. But full of surprises, Ganymede has a very thin atmosphere, or exosphere, composed mainly of oxygen, O2. This is not breathable. Pressure is about 1,000,000 times lower than on Earth. Scientists have also detected traces of ozone and hydrogen in the exosphere. Solar wind and intense radiation from Jupiter may alter the exosphere's chemistry over time, driving fascinating processes at the surface. Ganymede sits inside Jupiter's deadly radiation belt. Ganymede orbits deep within Jupiter's intense radiation belts, making its surface extremely hostile to both life and electronics. Unprotected humans or spacecraft would be destroyed in days by radiation exposure. Future missions will require advanced shielding or even underground bases to survive. This environment is a huge challenge for robotic probes and future human explorers. A member of the elite, Galilean moons. Ganymede is one of Jupiter's 4 Galilean moons, along with Io, Europa, and Callisto. Discovered by Galileo in 1610, these moons revolutionized astronomy by proving not everything orbits Earth. Ganymede completes one orbit of Jupiter every 715 days and is in orbital resonance with Europa and Io. Their gravitational interactions drive geological activity on all 3 worlds. Life beneath the ice, hope or fantasy? Ganymede's subsurface ocean may host hydrothermal vents like those found on Earth's deep ocean floors. These vents could provide heat and chemical energy, enabling life even without sunlight. Alongside Europa and Enceladus, Ganymede is considered a top candidate for life beyond Earth in our solar system. Discovering life here would be a scientific revolution, proving that life may not be rare, but common wherever there is water and energy. Ganymede in space missions and science fiction. Ganymede features in many sci-fi novels, games, and films as the site of future colonies, water mining bases, and under-ice cities. The ESA JUICE, Jupiter Icy Moons Explorer mission, will arrive at Ganymede in 2031, entering its orbit and conducting the most detailed studies ever. NASA is also planning missions that could one day drill through the ice and explore the ocean below. What we learn on Ganymede will advance not only astrobiology, but also the technology needed for humanity to colonize other worlds. The future of colonization, humanity's outpost on the edge of the solar system? Thanks to its huge water reserves and stable gravity, Ganymede is one of the top candidates for a future human base in the outer solar system. Any colony would likely be built beneath the ice, using local water for drinking and oxygen production. Power could come from nuclear reactors or possibly geothermal energy deep below the surface. Mastering life on Ganymede could be a stepping stone to exploring more distant moons, asteroids, and even the depths of Jupiter's system. Fun facts and numbers. Ganymede, by the stats. Density, 1.94 g cm3, a mix of rock and ice. Distance from Jupiter, 1.07 million kilometers, 665,000 miles. Orbit around the Sun, same as Jupiter, nearly 12 Earth years. Gravity, 1.43 ms2. You'd weigh 7 ox less than on Earth. Surface area, about 87 million kilometers larger than the entire African continent. Temperature range, 112 degrees C to 193 degrees C, depending on location and season. What would humans face on Ganymede? Science and sci-fi. Without a spacesuit, a human would freeze and suffocate in seconds. Radiation would kill an unprotected human in a matter of days. The sun would shine 25x dimmer than on Earth, but Jupiter would dominate the sky as a massive, colorful disk. Potential colonies must be hidden beneath the ice, with astronauts relying on local resources for survival. The future of exploration. Why Ganymede is key for science and humanity. Studying Ganymede will help us understand how moons and planets form and what it takes for life to arise. Technologies developed to survive on Ganymede will be vital for future missions to Mars, Europa, Enceladus, and beyond. If we discover life on Ganymede, it could mean the universe is full of ocean worlds harboring life, from microbes to perhaps more complex forms. Ganymede, not just a moon, but a world of possibilities. Ganymede isn't just an icy ball orbiting Jupiter. It's a dynamic, geologically active world that could turn our understanding of astronomy, biology, and the future of humanity upside down. Is life hiding beneath its ice? Will technology built for Ganymede unlock deep space for human settlement? Next time you spot Jupiter in the night sky, remember that hidden in its shadow is a moon that could change everything we know about the universe.